function will cost less money, okay, when you buy it, and will cost less money to operate it. Okay? The two factors that always come to business physics. I will do things differently if I can have a direct and clear benefit. Then we have the motivation to move. And what we see basically today that in most of the cases, okay, the end value of moving depends on the application itself, okay, and each application, each function needs of a detailed analysis by itself. This means that not everything can be virtualized, and neither in the short term and maybe in long term. So here is a kind of map, okay, of what we see, elements that could make sense to put into the cloud to get virtualized. So basically, you see that is in the short term are functions, applications, control plane, management platforms, mobile packet gateways. This is the, for example, the GSN, the GSN, SGA, the gateway of mobile network. Function that in some way are more related to computing and memory, okay, are the perfect candidates for analysis to take to the cloud. While on the other hand, we have any device, any technology that is very linked to the physical media will never be virtualized. For example, you cannot virtualize the fiber or the DSL access you have at home. So you cannot virtualize the microwaves. You cannot virtualize for example, today, at least not today, and in long term, does not seem to be feasible. A core router that is moving terabytes, okay, moving that switching capacity onto an Intel platform, does not seem to be feasible, right? So the more the function is linked to the physical or to the muscles, okay, to function, the less interest on virtualizing it will have. Okay. So basically, just putting what I mentioned in a more schematic way. So we have devices that, if we make analysis on the device, the telecom device, is basically working with storage, computing, and memory, okay, as its major assets. Then, basically, that is what a server is. Okay, at the end of the day, a server is some networking bed, is hard disk, RAM, processor, and RAM. So this is what we can have maybe in a typical way in a standard server into a data center. And what we are doing is just adding all the elements that allows a function or application work on virtualized environment. This means a virtual machine into our data center is a number of different servers with a number of CPUs and a number of elements that can be handled as a whole, and we can do these elements, the hypervisor, the virtual switch into a hypervisor, and the orchestration to make this work. We can allocate, we can assign to a certain function, CPU, memory, okay, and storage on demand. Okay? And if we can move, if we can move to a kind of a standard way of doing things, we will have a function running with a lower is 0. Okay? And where does the SDN help on this? Basically, the SDN will help in the same way. We will have the applications and functions running on servers, whatever they could be. That is the cloud. So a server could be locally, or it can be more centralized, or distributed. It can be in a data center in the US or whatever. Okay. We need to connect the end user, okay, through the network down to, or we need to connect to the application or the function, and it means that whenever an application is appearing for certain subscribers, so the application is saying, here, I am the application for you, the end user does not need to know where it is allocated, and does not need to know which type of networks or through which type of devices the traffic is going to pass through. So this is where the SDN helps. Basically, whenever we have this application has a number of network processors of resources allocated to work, the SDN, what the SDN will do, okay, is to from this centralized brain will create dynamically the connectivity between the applicational function within the data center or among data centers and up to the end subscriber. So SDN at the end of the day stands for creation of connectivity between the elements that are needed to work together to provide with a certain service to an end user. Okay? Well, it could be from the user to application, from the different elements that need to talk together to provide with the service, but whatever the creation of connectivity is needed, this centralized brain, okay, will configure whatever is needed end to end to make the whole thing work. That means that, for example, if you release an application in the cloud, or you request for a kind of storage, okay? The connectivity. So I go to a web page and I say I want a 1 terabyte of hard disk, for example. Okay, but that is not. That is more things need to be created. So basically, the communication between my home and the storage capabilities I rented needs to be created as well. So, and that is where the SDN comes to play. So if we see the network as a whole, so basically this is a standard scheme of carrier network. We have the access devices. We have the access. We have this is the first layer. Afterwards, we have a kind of aggregation, typically a metro layer, and aggregating all the metro layer, we have what we call the core network. And afterwards is where we are used to have the centralized elements that provide with services to the end users. So, all these layers are typically constructed with the traditional telecom devices. On top of that, what we see that we will have all this cloud ecosystem of functions, applications, whatever, that will be into data centers that will be either centralized or distributed, on the whole thing, okay, the communications to make the whole thing work together, okay, will be handled by what we call the decentralized SDN controller, or what we basically a federation of controllers. So basically, from one single brain, you are not able to control thousands of elements on applications to deliver. So there will be a number of those, okay, that working together can carry on with the task. Okay. So these are as an introduction. In a more, I will try to go in a more deeper way on overall in the piece of the telecom, right, where the SDN is playing today. Okay, and today SDN is working in 3 environments that could be summarized into 2, but basically the first point where the SDN technologies are being deployed is into the data centers themselves. Just as far as the number of applications and the number of subscribers that are getting services from the cloud is growing, the automation that the SDN brings, it needs to be applied. So this is the first point where the SDN is to be worked on. And the other 2 and 3 are related to the applicability of SDN throughout the network. Okay, we see is to make up. One is basically automation and configuration of services end-to-end. Okay, basically how this centralized brain can help me to construct circuits from any point of the network to other. And the other one is here is described as traffic engineering, but basically it means the coordination between all the layers from the network to work together in an adequate way. Basically, when we set up a connectivity today through the internet, okay, we have an IP connectivity. But on the line IP, we have all the muscles that the optical layer needs to bring. So in order to provide with the bandwidth on the service in the most optimal way, we need to coordinate, okay, the establishment of the IP connectivity with the underlying bandwidth that the WDM, for example, is to bring to the upper level. Okay, so the coordination between the two, okay, and the coordination helps us to construct the network in a cheaper way. Okay, because in actually what this doing is basically the carrier. One department it works out, designs and deploys the IP network, and a different department deploys the transmission network. Okay, that means that both departments working alone, okay, construct and define the network with resiliency, bandwidth, with data. Then both are reserving bandwidth without taking into account what the other is doing. That means that, for example, per gigabit, the IP network needs to carry, normally, the network is designed with 2 gigabits. Basically, in order to have a restoration path, and basically when one part of the network fails, there is another way to carry traffic. Basically, the IP guys planify the network as such, but the optical transmission guys do the same. So basically that means that when there is no coordination, typically per gig or per gigabit, you need to carry through the network, you, at the end of the day, you construct 4 gigabits. 2, to provide resiliency at the IP level, and 2, to provide with resiliency again throughout the optical layer. So a proper coordination between both layers, okay, can help you to construct the service end-to-end with less resources. That is here what is done for traffic engineering. Okay. So if we begin data center, basically SDN, and going to deeper, I mentioned that was a way to define connectivity end-to-end. Okay, in order to work this connectivity in a proper way, and in order not to avoid the need of programming each device end-to-end from the network, at the end, it creates abstractions of the network. That means that somehow what they call the central brain, the ethic controller, takes the information of the service or the application, basically which bandwidth needs to work, which type of creative service, latency, which elements within the data center need to be connected among them to make it work, okay? Translates it to service attributes, okay? And makes a kind of, it's an abstraction, okay? And it defines the connectivity and the attributes that are afterwards downloaded to the network elements itself. That without knowing exactly, we still need to know which elements, exactly which elements are working to provide the connectivity. So, being trying to explain this better, is basically the SDN controller into a data center that will be different in the, as we will see, the weather network, does not exactly need, okay, to know all about the elements on the line, okay? Because we construct the communications in a kind of overlay way. So why these SDN technologies came to play in firstly into a data center? How does the data center work? Like most of the data centers, okay, work like this. We have the network itself, the switch in the data center is the working with the data center, network that helps the servers to connect among them. We have the servers, okay, computing, memory, and storage. Okay. Whenever a communication needs to be applied within the center, there are tools that discover the resources of the network itself. There are elements that create or configure the virtual machine, whatever the server is. Afterwards, when this virtual machine is created, the orchestration system looks for storage capacity and communication capacity. Okay? If by any chance the allocation of any of the elements into its phase, the process needs to begin again, right? So basically, right now, there are very complex brains trying to work together only to create a service that is based on a hard disk, CPU, and the RAM. So this is why the SDN has been applied first in order to take out all this mess. There are big operators, for example, the case of Telefonica, that due to this have been unable to provide with cloud services as such, because the mess they created to try to make all these elements work together failed. Okay? So what we are doing is simplifying the whole thing, okay, with three principles that have been working for long in the network. One is what is the having the intelligence of making decisions within the network. The elements are the edge devices. That means that we are only making deep configurations, okay, on the first elements where, okay, the user is connected to the network, and the inner elements of the network are only moving packets without being aware of the services that are running on top. Okay, this is one principle. Basically simple that you do not need to touch all the elements end to end to provide with the service. Only the extremes through which the connectivity needs to go through. Other thing is that as far as at the end of the day, in order to build up a connectivity in a complex interface, The complex network needs to pass through different type of networks. Okay.
Question.
Yes.
What does what does the intelligent actually?
Yeah. So basically, it means that we need to simplify the elements where you make the complex configuration of a service. Okay, you are basically trying only to touch in the border, okay, of the network and the inner elements of the border is what we call the edge, okay? And the inner elements of the network are not service aware, are not subscriber aware, are only dump packet movers. If I would say so, you take the complexity only to the edge, the border of the frontier of the network where the subscribers or it's are connected to, okay? And the rest, okay? And this is where you configure or you download the profile of the subscriber, the quality of service, and with authentication requests. And the inner elements are not aware of all this type of profile.
So that's not really intelligent, but service starting.
Right. That's it. Yes, please. Okay. The other thing is how to standardize or how to make a number of different elements work together from the control plane perspective. We are promoting the usage of this protocol, this BGP. BGP is a no standard protocol. BGP for you don't know it, basically it's a protocol that can carry on a lot of information, right? So different information, and you can extend. Basically, what we are doing is to standardize the extensions of BGP in order to carry on more type of information, right? So it scales all the internet, basically worldwide works with BGP as the master control protocol to exchange the raw information world, right? So it scales it. Why not to extend its usage to carry on more type of information? And the other thing we are using is the policy-driven scheme that the mobile networks work with. Today, when you switch on a mobile phone, whatever you are, okay, you make an authentication mechanisms. You are authorized or not to get the network, okay, and you are downloaded a profile, okay, and this works for millions of devices. Right. So this policy centralized, policy-driven mechanism, okay, is already working. So we are using as part of the SDN a similar architecture where all the subscribers and application have its profile in a policy controller, and when this subscriber application appears, its profile can be downloaded exactly in a similar way through which it is done today in a way. Basically, it's a matter of scalability, okay, and help with complex structures of policies, okay, to be instantiated throughout the network. Okay, basically, this is I will go. What is I use one. I don't like to use product slides, but I mean, this helps to understand a little bit about the content. Basically, how we work is with notions, and this is the name of our product. But basically, what we do is we define graphically how the network looks like. We configure it in a web page. Okay, that comes to a directory. Okay, it's something like a policy server, and it is downloaded. It comes to an engine that is the engine controller that converts this abstraction of the network, okay, and makes the specific orders, in this case typically software flow, the protocol use, establish the orders to all to the elements, to the hypervisors or routers through the network, okay, makes the proper configuration to make this drawing, this abstraction, be a reality throughout the network. So basically right now, look at it only into a data center space, right? How, in comparison to the schema I showed previously, what we how we work or how we see the network is we have a number of switches or routers in the data center. That is an IP routing environment, okay? And we have the servers that have also inside some switching, okay? And what we do is we work in an overlay mode. We construct communication from the virtual machines themselves to other virtual machines through the. Basically, what we do is when a virtual machine in the network is created, we detect that virtual machine is created, right? And automatically, through the policy server, we configure the tunnels, the communications that are needed to make the application or function work end-to-end. Right? In a similar way, when a virtual machine moves or disappears, we detect that this movement is happening and dynamically, okay? We create again the needed communications to make the whole thing work. From a single point, the communications end-to-end are created. This is basically an SDN overlay type of applicability. And another thing, how we see the control plane evolving is what I mentioned, that we are considering BGP and the standard protocol to let the SDN controllers talk about among them. An SDN controller, at the end of the day, will be able to control, okay, limited number of communications, devices, or applications. So we will need more SDN controllers to cover the whole network. So basically what we do is through BGP, we federate whatever the number of SDN controller instances could be needed to make a healthy work, okay? And the whole system behaves as a single SDN controller with theoretical infinite, okay, scalability and capability. Okay? Basically, the number of elements that can be controlled through this model is huge. It's very big. So theoretical infinite element. Okay? And also another thing that we see that is we have been talking about the networking within the data center. So we have one element typically in the frontier of data center towards the wide area network, okay, the virtual network, that is an edge router. So what we do is to put the edge router, okay, as if it was an SDN controller itself. So basically, the router that is already touched BGP touched with the SDN controller elements as if it was another one, okay? And this element changes the this BGP iteration towards standards, for example, IP MPLS controls lane signaling, data lane, okay? End-to-end to provide with connectivity between the end subscriber, or this kind of case of an enterprise, for example, towards the application or function that is running into the data center. And basically, as a summary, basically the need of the applicability of SDN into a data center comes from the fact that right now, okay, we all, okay, the number of users that could be renting or getting services from the cloud has been multiplied by thousands. I mean, not too long ago, the only customers of cloud services were big enterprises. Right now, the market has changed, and the number of potential subscribers getting service for the cloud is huge. So the operational mechanisms that needs to be implemented in the data center needs to change for a more automated mechanisms that could allow, okay, thousands of orders and requests being handled properly. If we come to the wide area network, okay, I will not extend my speech on this, but basically, one of the first applications of SDN to the area network is to construct type of virtual private networks overlying the existing infrastructure. This is what we call software-defined VPN. Basically, today, when an enterprise requests for connectivity to an operator, okay, you get a device into each of the office, some capacity towards the network, towards the customer network, and it is created an ecosystem through which only the elements within this VPN can see each other. Right now, these terminal devices are quite proprietary and quite specific to the needs of the VPN. Okay? Something that, and by extension, they are normally quite expensive. Something that SDN can bring is that we change this kind of very, very specific customer premises element, the CPE, for a kind of element that is also like a server, an Intel-based element that could be understood as a server, even like understood as its behavior as a server into a data center. So we can control it through the SDN in the same way through which we were controlling the communication with a data center. Okay, that is what we call the virtualized type of CPE. Basically, what we will have instead of a kind of complex environment through which we are to configure the CPE, this communication, the provider, each router, the communication end-to-end, and the communications up to the data center, step by step, and through different application noise system, we have, by the applicability of SDN technology, the capacity of constructing, okay, all the communications from the office of our customer directly towards or up to data center and among them, okay, from this centralized range, okay, as far as we will have a similar type of element within the data center, servers, and an element, a telecoms element that is working exactly like a server. So we set up communications among these elements, okay, in the same way, with the same automation and dynamicity as we serve into the data center. This means that we take out the element on the office, we change for a kind of Intel, for example, base router, okay? And through OpenFlow or through SDN protocols, we are able to configure from a central and unique point of control the communications endpoint. Basically, what we are doing is we can take the intelligence, either data center, centralized, more distributed, or up to the customer premises. We take the definition of the service, and what's more, we can define value-added services, okay, wherever is more interesting to have them. I mean, for example, a firewall could be centralized, could be semi-distributed, or we can even have, for example, a firewall, okay, at customer premises if this is the more adequate way to work. Okay? Constructing from a single point of configuration, single point of intelligence, the communications for the network endpoint. Okay? This is one example of applicability of SDN. The other is in the same way that we are going to have a lot of dynamic services and applications within the data centers, whatever it could be. Okay? The network, the network, whether network, basically the huge network infrastructures, will need to react as rapidly, as fast as this network and application system within the data centers are. I mean, it is useless to have very quick services and applications or whatever activation within the data center if at the end of the day we cannot also configure the communication from customer, from the enterprise or whatever towards this new service application as quickly as it is created here. Okay? So we will need to be agile in the creation of services end-to-end. The major difference on this agility between the network with the data center and the weather network is that the resources here are much more expensive. Okay? So with the data center, we have, for example, bandwidth is not that important because we have basically the switching here is a kind of could be a kind of switching of with terabytes of capacity with a very kind of reasonable cost. But in the weather network, we have all the civil works to put the fiber on. We have the WDM, we have the routing. So bandwidth in the weather network is much more expensive. So basically, the control of this bandwidth, or how we work here, the fine-tuning and the knowledge of the resources that are available in this piece is much more important. Okay? Because at the end of the day, it is much more money if we do not make the focal decision. So basically today, how it works is that, for example, if you want a lease line, you need the communication from typically from an enterprise, because or basically when you want to have your home, your internet access service running, it can take days or even weeks, okay? Because all the configurations, all the configuration of systems or elements, element by element, you need to configure the access network, you need to configure the relation network. Okay? Today, it's very slow. So basically, it does not match with the requirement of being fast or building the communication as fast as the new application or new service appears. Okay? I will skip it. So basically, here, what we need to do is two things. On one hand, what I mentioned is to make the IP running, the IP network, and the optical and control network work together in an efficient way. Okay? And the other thing is how we can leverage or we can somehow use the technologies that are working in the data center to be applied elsewhere in order to allow us to have the same dynamicity, okay, the same agility to what we will have in 20%. Okay?
Question.
Well, yeah.
In the previous one, does the IP routing contains the, for example, optical routing, which is also very fast at home?
No,
actually, what is about optical routing? Because optical transport, I mean, a method of implementing the signal into the, for example, fiber, and IP routing is the method of routing actually.
Yeah, but optical transport has also another, it's more than that. Okay? You're not only putting the signal, it's multiplexing, okay? Is rooming single source is creating networks based on lambdas, okay, with all the complexity it has. So basically here we should let's look at here. Basically this is about managing lambdas onto a fiber, okay, and this is has its complexity itself, and this is about moving packets, right? So, but basically to move packets, I need the muscles of this layer, okay? Basically what I'm trying to mean here is that how to really make more dynamic, how to inform, this is what it here comes to, how to let, for example, the optical layer know what is the needs of the IP service in order to automatically configure the lambda, for example, that is needed for certain IP service end-to-end. Okay? So, and this other, the IP optical integration is something that has been trying to standardize for years. Okay, it looks like this could be a reality. But basically, for us, it means three things. Basically, coordinating the the data plane. Basically, that an IP flow matches a lambda automatically, for example. This is the data plane. The other thing is that control plane, basically, that the router can talk to a transport device to make a request to ask him, I need the bandwidth, or basically on the other way around, if there is a failure throughout the optical network, okay, this network informs automatically the IP network that this failure has happened to make our routing decision, right, in a fast way. And the third point is managing all together like a single network instead of having two networks operated completely separately. Okay? So this one way, and we need to add on top this SDN technology in order to make this whole thing happen in an efficient way. Okay? So basically, we come to a situation where we can have the SDN overlay. Basically, the SDN overlay is somehow, some people see it as configuring all this stuff related to a router. Okay? We see it as a kind of, also right now in the very short term, we have the router, the distributed control plane. So these central brains, right now what we see is that will help us to modify the decisions that are being made at the IP network, okay, to allow us carry traffic independently. I mean, this is what is we can see it as a traffic engineering, okay? And on top, what we are doing is taking the SDN controller, this traffic engineering tool, okay, also not only to modify the decisions of the routers, but also to include decisions of the switching, lambda switching and the optical transmission work together with the routers. It means that there will be a single control plane. Okay, if we look at IP and optics, there is a protocol that's called GMPLS. Okay, that basically allows the communication between IP and optical layers. So on top, you see, and many operators are working on that well, is to have a centralized brain that could allow us to have traffic engineering to modify end-to-end the decisions of both layers working together to provide with this agility and to provide with the optimal paths to make the whole thing work. Basically, so this means that right now we can understand the network as it had three layers. We have the optical layer, okay, WDM, lambdas, roaming, this pure transport. We have the IP layer. It's typically whenever today we talk about IP in a carrier environment, it's called IP MPLS, right? So the IP layer and what we call the service layer. A service basically is understood as the number of the different connectivities on the line working all together in a kind, even for example, in a multi-point environment. So it can be the number of point-to-point circuits that we could work here and here, working all together to build this kind of, we call it also a cloud. So basically, how SDN will help the construction of the services throughout the network in the metro, and while the network is trying, instead of having one layer on top of the other, is parallelizing them three, okay, in order to have resource control, okay, of what is needed for each service end-to-end from a single point of view. This means that basically we will be able to even get a more virtualized vision of the network, because by working with SDN, we can even construct virtualized transport contexts in a per flow basis. I mean that basically instead of having like we have today MPLS type of virtualization, okay, in a single type of VPN, we can in a per flow basis we can have different type of traffic customers running on top in parallel in on its own without interfering one to each other. To make this work, on top of this intelligence that is able to configure the IP and optical and service layer, we will need another element, that is the PC, that is the path computation element, as I mentioned previously. In a different way to how the network into a data center works, here we need to have a very detailed inventory of the available assets end-to-end, because they are very expensive. We need to provision. We need to make sure that we are using the more optimized assets end-to-end through network. And this is what not the path protection element. This is the intelligence that is getting information from the network, basically from some topology, which type of layers, information about latency, information about whatever the detail of network we could have, in order to have a very detailed information of what we have, and to share even this information with other basically to have a clear resource manager working. That is something that is very first steps into the standardization bodies. Okay, but for the wider network, for the minutes, we need to really have a lot of information on how the network is performing at any level, to really be able to be agile and to provide with the transport services end-to-end in a more adequate way. So basically, you go to the IATF. The working group that is leading this is the ABNO. Okay, for example, and all the major operators worldwide are trying to define this element that could allow them to really change the way they operate networks, and really looking to be much more agile in the construction of communication services to what they are today. Kind of very leading topic in the financial bodies for carries into the way they're network. So I'm going with basically how our vision on how the network will look like in the next, could be 5 to 10 years. So we will have the network as we understand it today, basically access network, aggregation, edge, core, IP layer, optical layer, data centers centralized, more distributed, where the services are instantiated, and a kind of common end-to-end SDN control plane that will help to configure and to set up all the communications as per the needs of the application running into any type of data center. So I think this is a major thing, a major change to what we have today, where we need today to touch here, towards here, towards here, here, okay, and link it all together in order to set up a service. And this today could take weeks or months on establishment. Basically, this is all what I had for today. I know this is very technical, but if you at the end of the day got one or two ideas, for me it will be more time. Okay. Any further question? Any doubt? Shall I begin again, or? It's okay.
Are you going to upload the slides?
Yeah, I can disagree. If you're interested in them, I will. There's no secret one. Yes. Yeah, I will send it. Okay, one more difficult than that. That was easy. Okay, it's okay.